here's the solution to a problem where we have to identify what transformations are creating the graph of the parabola that we see here. Now I've already gone ahead and drawn a few points on this parabola that we're trying to find a function, well, on the graph that we're trying to find the function for. And I've highlighted points that just have nice whole number coefficients. So we can see the point 0, 0, we can see the point 2, 1, and we can see the point 4, 0. 2, 1 is particularly significant because that's the vertex. Oops, 2, 1. 2, 1 is the vertex. We also have 0, 0, and 4, 0. So the question here is, how did that shape come about from a transformation of f of x equals x squared? So like I said in class, the first thing you would try is to just transform this picture directly from here to here without any kind of scaling. And if you try that, it doesn't quite work. So that's why this question is a little harder. It's one of the ones that's a little further into the problem set, because the first thing we're going to do with this function is think about how it would scale, how putting a number in front would scale it. So rather than start with the f of x equals x squared, I'm going to override that and say, well, we already tried that and it didn't quite do it. So I'm going to start instead with a function that looks like f of x equals a times x squared. Putting the a in front just scales vertically the graph. So if a were something like 3, it would create a really tall, skinny graph. If a was something like 1/10, it would create a super wide parabola. And if the a is negative, it's going to flip the parabola over. And so you can kind of tell that's what's going to happen here. So by starting with this generic form, that allows me to do the transformation of moving this vertex to the new position, and then to figure out what that value of a would have to be in order for the parabola to hit these other points. So I'm going to do it in 2 steps. I'm going to make my vertex of this move to this position, which I can do by shifting, and then I'm going to figure out what the scaling factor has to be so that that picture also hits these other 2 points. So the shifting part, step 1, is pretty straightforward. I need the vertex to go over 2 units and up 1 unit. So if I say g of x is f of x minus 2 plus 1, we have learned that that shifts the graph of f over to the right 2, and then putting this plus 1 makes the graph of f go up by 1. So that's what the formula would look like. That moves the vertex over 2 and up 1. And so in terms of the actual function here, that would be instead of a times x squared, I would be a times this thing squared plus 1. So this is what my parabola has to look like in order to have the vertex of the parabola move to the point 2, 1. So any number at all here for a, this is going to be a parabola whose vertex is at 2, 1. So the second part then is figuring out what a has to be. And I can do that by taking either one of these other 2 points that I've picked, that I've marked. This one's not going to help me because every parabola of this form is going to go through that point, so that's not useful. But either of these 2 points is going to give me some more information. So let's just use the one here. It doesn't matter which one we use, but so I'll circle the one that I'm using so you can tell. And so from that point, I know that g of 0 should equal to 0. Right? So that's the input and that's the output. And again, it wouldn't matter what other point I had here. Any other point I would have is going to tell me something about an input-output pair. So for example, I also know that g of 4 equals 0. But I just have to pick one. And so g of 0 is equal to 0. from this blue box that I have up here, from this fact, I know that g of 0, and here I can just plug 0 in for x. So if you put 0 in here for x, and this is g of x, so if x becomes 0, then this becomes 0, and I'll have a times negative 2 squared plus 1. Negative 2 squared is 4, and so the equation here is going to be g of 0 is 4a plus 1. So plugging 0 in for x makes this side say 4 times a plus 1. And so I know both of those things. I know that g of 0 has to be 0 because of this point, and I know that g of 0 is 4a plus 1 because of this. So if g of 0 is both of those things, that means those two things have to be equal to each other. So therefore, 4a plus 1 must be 0. And from there, we can determine that a has to be negative 1/4. And we knew the a was going to be negative. A scaling factor of a negative number is going to turn this graph over. It's going to make all your y-coordinates become negative numbers. That's what makes it go this way. We didn't know exactly what that number was, but I can now check. Well, let me write my answer in the box first. So my answer would be negative 1/4 times x minus 2 squared plus 1. And it's easy to check because I can check a few values. I can check g of 0, and I'll find out that g of 0 is 0. I can check g of 2. I'll find out that's positive 1. I can check g of 4. It'll turn out that that's 0. So by plugging some numbers into this answer that I've written down, I can check that it really is hitting all the points that it's supposed to hit.